Hi boys and girls, welcome to the video on how to complete the Don't Soil Yourself assignment scheduled for week 4 of online learning. So if we take a look at the directions here, the first thing it wants you to do is open up this video, which you will find the link here. We have the questions to answer, so we want to open that first and download the questions, and a video on how to do that is located here. So I'm just going to pull up the questions for you so we can first take a look. So at the bottom of my page, here are the questions that you need to answer. So what we're going to do, what I want you to do is you may just want to use this video to answer the questions. I'll give you some pointers, or you can use the Dynamic Earth PDF file. It's a large file with a bunch of topics, and we want to find Lesson 5, a picture of that section is up at the top left. But let's just take a look at the first 3 questions. Question 1 says, what is soil? Question 2, how does soil form? And question 3, what is, this word is pronounced humus, not hummus. That's something that we eat made out of chickpeas, but this is humus. And why is it important? So humus is something that we find in soils, and we will find out what it is. Okay, so we're just going to focus on the first 3 questions here. And I'm going to go back to Classroom, and I'm going to bring up the document. Okay, so when we first bring up this document, it doesn't start at the right section. So it says Lesson 4, Erosion and Deposition, and we already talked about that. This file, the reason why I included this for this lesson is because it has a lot of good stuff in it, and it has particularly good information on soil. So it has extra stuff that we already learned about. So we want to keep scrolling until we find Lesson 5 on soil formation, and there is a picture of a large mushroom, I believe, a fungi on the front. Oh, here it is. So this is where we want to be in our Word document. Sorry, in our PDF. So this is a PDF file. You can download it if you want to save it on your computer. That way you won't need to go back into Google Classroom to open it up. So you can do that if you want. So we don't want to look at this stuff. This is just questions for you to engage your brain, think about how much you already know, but you do not have to answer any questions embedded in this PDF file. Okay, so here's where we want to start. So if we look at the bottom of the page, it says 58. So I said to start on 56. That's the beginning of Lesson 5, right? But we want to really start at 58. So it says the dirt on soil. What causes soil to form? Soil is important to your life. You walk on grass that is rooted in soil. You eat foods that need soil in order to grow. But what exactly is soil? Where does it come from? How does it form? A scientist might define soil as a loose mixture of small rock fragments, organic matter, water, and air that can support the growth of vegetation. So you can include this for question 1. I'm asking you what soil is, and you can type this word for word if you'd like, because this is a good definition. The first step in soil formation is the weathering of parent rock. And we learned about what weathering was in our previous topics. So weathering can be caused from heavy rain, or can be caused from particles carried by wind that constantly hit a rock. Weathering can happen from freezing and thawing of ice, from glaciers, a lot of different things. So the first step to breaking down rock to make soil is weathering of parent rock. That just means whatever rock, igneous, metamorphic, or sedimentary. Parent rock is the source of inorganic solid soil particles. Soil forms directly above the parent rock. Soil either develops here or is eroded, which technically means transported. So the biggest difference between weathering and erosion is that weathering is just the breakdown, whereas erosion technically is the transport of that broken down rock. or is eroded and transported to another location. Okay, so how does soil form? You can say it happens when rock is weathered. Weathering of parent rock. Weathering breaks down parent rock into smaller and smaller pieces. These pieces of rock eventually become very small particles that are mixed in with organic matter to form soil. The process of soil formation can take a very long time. The amount of time it takes depends on many factors you will learn about later in this lesson. One thing I want to point out, boys and girls, is that sometimes there's extra stuff on the page. Feel free to read that, but the answers will not be in these smaller parts of the page. They're going to be in the main reading here. Okay? All right. Decomposition and mixing by living things. Some microorganisms. These are living things that we would need a microscope to see, boys and girls, and there are trillions and trillions and trillions of these things everywhere in the soil, inside of our bodies, like our stomachs to help us digest food, on our skin. The ones on our skin and inside of our bodies actually help us, but there are some ones that might hurt us. But anyway, bacteria and fungi are decomposers that live in soil. These tiny decomposers perform the important task of breaking down the remains of plants and animals. These remains are decayed organic matter called humus. So there's your humus. The remains are decayed organic matter. So something that was alive, a plant or animal, that is being broken down by these tiny organisms like fungi and bacteria. So there's your humus. It's actually organic matter. Humus is found in the top layer of soils. It is important. So here is our next question. Why is humus important? It is important because it contains nutrients that plants need to grow. Plants take up these nutrients through their roots. When plants or animals die, they are broken down by decomposers and the nutrients are returned to the soil. Larger animals such as earthworms and moles also live in soil. They loosen and mix the soil as they burrow through it. The mixing increases the amount of air in soil and improves the ability of soil to drain water. So we want earthworms and small things to be in the soil. If you find worms in the soil, leave them there. It's a good thing. So again, we don't have to answer these questions. We're going to move on. Oh, there's a picture of our little microorganisms. So this is magnified. We couldn't see this with just our eyes. We would need a microscope to do so. All right, next question. So I'm just going to jump back here to our document. So we answered 1 through 3. Now we are, this should be, actually, I messed up the numbering. I'll fix that. So our next question is, what 4 factors determine how long it takes for soil to form? Okay, those 4 factors, we're going to jump back to our document here. Okay, so what factors determine how long it takes for soils to form? Soil formation and development are processes that take place over a very long period of time. There are 4 main factors in determining exactly how long these processes take. So here we have our 4 factors: rock type, climate, topography, plants and animals. So boys and girls, you can just list these. Okay, you don't have to type out the whole description next to each word. So you can simply type rock type, climate, topography, plants and animals. So what it means: rocks can weather at different rates, depends on the rock and the minerals in it. Soils usually develop more quickly in warm, wet areas rather than in cold, dry areas like maybe the Arctic. Topography: sediments on steep slopes are often eroded. Soils usually develop faster in flatter areas. Plants and animals: plant roots hold sediments in place, allowing soil to develop quickly. Areas teeming with life have higher rates of decomposition and mixing. Soils tend to develop more quickly in these areas. Without a lot of plants and animals, soils tend to develop slowly because we need that humus, that organic part of the soil with all that decaying matter. So we want plants and animals to be abundant, which means a lot. All right, so we are actually going to skip this page. It kind of talks about the different layers of soil, which we're not going to get into. Okay, what we do want to remember, though, is that we find humus at the top layer, okay? So here we get into properties of soil, and this is what we're going to use to fill out our chart. We have texture, 3 different types of soil and their particles. They range in size and they have different qualities about them. Plants grow well in some soils and poorly in others. Soils look and feel different. They also contain different minerals and particles. Soil properties are used to classify different soils. These properties include soil texture, color, chemistry, pore space, and fertility. The term soil texture is a property that describes the relative amounts of differently sized soil particles. Soil particles are classified as sand, silt, or clay. Most soils are a mixture of all of these. Sand is the largest particle, ranging from 0.05 mm, stands for millimeter, 1,000 of these in 1 meter, to 2 millimeters. Soils containing a lot of sand feel coarse. Silt particles are smaller than sand. They range from 0.002 millimeters to 0.05 millimeters. Silty soils have a smooth, silky feel at less than, Sorry guys, let me go back to what? Okay, I'm just gonna open this. This is a little bit bigger. Where were we? Okay, sorry about that. Soils containing a lot of sand feel coarse. Silt particles are smaller than sand particles. They range from 0.002 to 0.05. Silty soils have a smooth, silky feel at less than 0.002 millimeters. Clay particles are the smallest, and they feel very smooth and usually sticky when they are wet. So here's kind of a size comparison for you. Okay, so I think we're going to pause here, and I will make another video reading the remainder of this lesson, which we talk about some other things like how soils are different in different climates. We're going to talk about their chemistry, pH, pore space, and fertility. Then we're going to stop here. So open up the next video to help you with the remaining questions.